This is a video for section 3.2 of Math 1 on direct variation. Alright, so let's talk about what we mean by direct variation. It's essentially a relationship that can be represented by a function in the form y equals k times x. This is very similar to what we learned for section 3.3. This is kind of backwards for slope-intercept, which was y equals mx plus b, right? Except we don't have a b, because it's 0, and m is being replaced with a k. K is called the constant of variation. So essentially, x, which is right here, gets multiplied by some k. And that's it. Nothing gets added at all. Just multiplied. Now, k could be a fraction, so it could look like it's dividing. K could be positive or negative. The only thing that k cannot be is 0. And so when we see this, what it means is y varies directly with x. So let's look at some examples of some situations where y and x are varying directly or indirectly. Okay, well, not indirectly. We're going to do just directly. Okay, so first let's just look at some equations. So, for example, y equals 2 times x. So k is 2. So this is a direct variation. Y is equal to x plus 3. If we're adding, that is not a direct variation. Let's say we have y plus 3x is equal to 0. Now this one's kind of tricky because I can move that 3x around by subtracting it. I can move it to the other side. And then now I have y equals negative 3x, and now there is your k value. So k is equal to negative 3. So this is a direct variation. It's just we had to move things around a little bit first. Let's look at one more. This one's in your book on page 176. It says 4x plus 5y is equal to 0. This is similar to this one. You can move the 4x over, and now you have 5y equals negative 4x, and then you divide by the 5. This goes away. You get y equals negative 4/5 x. This is a direct variation. There's the k. So then let's look at some problems where they're going to ask you about like what variable or how to find the k. Okay, so how to find the k value. Okay, so how, oops, wrong pen. How to find the k, the constant of variation. So let's say that they gave you a problem that says this. Suppose y varies directly with x. So they're telling you that this relationship exists. And then they give you some more information. They say, and y equals 10 when x equals negative 2. So there's two parts to the question here. First part is, what direct variation equation relates x and y? So in order to find this, you need to find k. Alright, so we have this y equals 10. And we know that, let me use a better color, We know that y is equal to 10, and we know that x is equal to 2. So we're going to take this equation, y equals k times x, and you're going to take this negative 2 and plug it in for the x, and you're going to take this 10 and you're going to plug it in for the y. And then we can solve for k. So we get 10 equals k times negative 2. So we could turn this around. It doesn't have to be k first. It could be negative 2 times k. Those are the same thing. And then we can see we just need to divide by negative 2. And then we found the k. That reduces to negative 5. So that's your k. So then I can take that k and I can write the entire equation. Y equals, and then I'm taking out this k and I'm putting in negative 5 times x. So this is the answer. This is the direct variation equation that relates x and y. But let's say we have another question. And the other question is, what is the value of y? So this is like B. What is the value of y when x is equal to negative 15? So this is using the one that we just found. This is using y equals negative 5x. So our k is negative 5. So really, it's just plug in x with negative 15. So take this negative 15 and put it in right there and solve for y. So I'm going to get y equals negative 5 times negative 15. Negative times a negative is a positive, and 5 times 15 is 75, and there's your answer. Okay, then you can graph these. Graphing these would just, so we could graph this one. Graphing these is just like graphing a y equals mx plus b, now that you know how to do that, except your b is always 0. So if I were to graph this, my y-intercept is going to be 0 every single time for a direct variation. And then the slope here is a negative 5 over 1. So that means we're going to be going down 5, right 1, or up 5, left 1. Now, I probably should have a nicer graph, but that's okay. So I'm going to go down 5, right 1. You can see it's falling from left to right, or up 5, left 1. And so if you ever have to graph these, it's just like graphing a y equals mx plus b, since we already know how to do that. Okay, another thing you might want to look at is the t-table, and looking to see if you have a direct variation from a t-table. So let's look at a case of that. So looking at a t-table, so a table of values. Okay, so we have our x and our y. Remember, keep in mind that we are multiplying x by some number k to get y. So let's look at our values and determine if you have a direct variation. We'll start with an easy one. Let's say I have 3, then negative 6. And then let's say I have a negative 1 and a positive 2. Then I have a 0 and a 0. And a negative 4 and an 8. So am I multiplying something times x to get y? So one way that you can do that is think of k as the ratio of y over x, right? Because I could just divide both sides by x, make this go away, and then k would equal y over x. So I can use that and see if I get the same number each time. So for this one, I can do negative 6 over 3. That gives me negative 2. Okay, and I'm going to do this one. That's 2 over negative 1. That gives me negative 2. Do you see how they get the same answer? I have to check all of them though. 0 divided by 0. Well, 0 divided by 0 doesn't really work because you can't divide by 0. And that goes to the idea that I divided by x here, and you can't really divide by x if x is 0. But x could be 0, so we'll come back to this one later. And let's do the last one. If I take 8 and divide it by -4, I also get -2. So I suspect it's correct, but the 0 over 0 thing kind of threw me. So let's check to see if k really works for the 0, 0. I'm thinking this is my k, -2. So that would mean that y equals -2 times x. So let's check 0, 0 now. Let's see if this works. Is this true? Yeah, because 0 would be equal to 0. So it does work. I just couldn't really divide by 0 there. So that's pretty much it for direct variation. The big idea here